When we describe the energy of most things, we use the SI unit of a joule. When we get into the microscopic realm, however, the joule as a unit of measurement becomes too large to easily deal with. So when dealing with microscopic particles, we have defined the electron volt. An electron volt is the amount of energy produced when an electron is accelerated through a potential difference of 1 volt. So when our electron moves through a potential difference of 1 volt, it is said to gain 1 electron volt of electric potential energy. Remember, we find the change in potential energy by taking the charge times the potential difference. Since we are dealing with an electron, we know that the charge is 1.6 times 10 to the negative 19th coulombs. We also know that the voltage difference is 1 volt because that's how we've defined it. Using those values, we can see that the change in potential energy of an electron moving through 1 volt of potential difference is 1.6 times 10 to the negative 19th joules. Now this is just one charge going through 1 volt. What if we have a double charge? We would have 2 electron volts. What if it moves through 12 volts of potential difference? Then we have 12 electron volts. So at the atomic level, electron volt is the energy unit most commonly used. So let's calculate the potential difference needed to give a 6.5 nanocoulomb charge 150 kiloelectron volts of kinetic energy. Okay, well, before we do anything, we need to convert that amount of energy from electron volts into joules. Because even though the electron volt is handy for stating the energies of tiny particles, it is not a proper SI unit. So for calculations, electron volts need to be converted into joules. Here we have 150 kiloelectron volts. So really 150,000 electron volts. And there are 1.6 times 10 to the negative 19th joules in every 1 electron volt. So multiplying that out gives us 2.4 times 10 to the negative 14th joules as our change in potential energy. We are actually looking for the change in kinetic energy of our charge, but we know that the change in kinetic energy is equal to the negative change in potential energy. In this case, the magnitudes are the same. So we're taking this divided by the charge of our particle, and we find the potential difference required to be 3.7 times 10 to the negative 6th volts. Now suppose an electron has 2.6 kiloelectron volts of kinetic energy. What is its velocity? Again, first things first, we are given the kinetic energy of the electron in electron volts. So let's convert that into joules. Then all we need to do is rearrange our kinetic energy equation to solve for velocity, and we find the electron's velocity to be 3.0 times 10 to the 7th meters per second.